Are you with Sarah?
Okay.
Oh, I gotta just go. Okay, chocolate snack.
So now we're gonna do stoichiometry. Now let me tell you a little bit about stoichiometry. How many of you guys have cooked?
How many guys what? Oh, me. I cook.
How many of you guys have ever baked a cake? From the box.
That too.
Okay, we're not going to scratch, okay?
The
From
box,
the box.
everything's pre-measured.
Okay, so if we're baking a cake from a box, if I'm gonna make one cake, right? How many boxes of cake mix do I need? Okay, don't listen to her. Okay, so we need one box of cake mix, okay? How many eggs?
2 or 3,
Three
depending on the
eggs.
cake.
3 eggs, okay, 3 eggs, okay? And how much butter? Because you gotta use butter, you can't use that. A stick of butter, okay, a stick of butter. Okay, and then how much water?
1.5 cups or 1 1/4 cups, something like that.
Okay. So it's like 1.5 cups. I'll say 1.5
I
cups.
made one the other day, it was like 1.5 or 1
Okay,
1/4.
perfect, 1.5 cups. Okay, so now that's the recipe to bake a cake, right? So your reactants are all of those ingredients, the cake is the product, right? Okay, so let's say we're gonna have a get together, right? And I know Brooke alone will eat almost a half a cake by
You know what,
herself.
that's really insensitive to my weight, okay?
That is not an insult to your weight. It's okay, because my cakes are good. That's the reason why you eat half the cake, right? And so, and then I know Jack will eat almost a cake by himself, right?
Well, yeah, 'cause he's got a fast metabolism.
So in other words, I know I'm gonna need a couple of cakes, right? So if I need 8 cakes to handle this class, then how many eggs am I gonna need? 24, because there's 3, right? Now, how did you guys calculate that? 8 times 3, right? But it's based upon our recipe, right?
Yeah.
So let's say our recipe was, write it down real quick. Maybe real quick. What was that? I can use whiteboard. Cake mix.
Yeah. Hey, did you get that honey's number? She was feeling you, Gabe. She was feeling you. You gotta get her digits. She likes you. What? She seems like a lovely girl. Oh, let's see. Yeah.
Okay, so you said if I had 8 cakes, I'm gonna need 24 eggs, right? Now, here, we're using that ratio because we know that for 8 cakes, we had a ratio for every 1 cake, it's 3 eggs. That's how you got that, right? Now, this is the same thing with chemistry, right? Chemistry is exactly the same way. That's why we need that balanced chemical equation, right? Because we're just working on a recipe. So if we look up here, this says we have 4 ammonias plus 5 oxygens. It's going to make 4 hydrogen monoxide and 6 waters. So we know that we're going to use a ratio, right? So if we wanted to look at the ratio between oxygen to ammonia, we know that that's going to be a 5-to-4 ratio, right? For every 5 oxygens, we have 4 ammonias. Now we know we can use this equation and flip it around any way that we want to. We can come down here and say we have 4 moles of ammonia and then 5 moles of oxygen. We can compare the oxygen to the nitrogen monoxide, or we compare the oxygen to the water. So if we have it already balanced, right, Mike? We have it already balanced. Tell your girl I'll talk to her later. Okay? It wasn't your girl? Okay. Okay. So anyway, if we have that ratio, we can sit there and determine how much of something that we need or how much of something that we can make. Okay?
Oh.
Okay, so using that last equation, if we have 3.2 moles of ammonia reacting according to the equation, how many moles of water will be produced? So we're going to start off with our given. We're always going to start off with our given. Here our given is 3.2 moles of ammonia.
Yeah, you do.
Okay. We're going to use that equation that we just saw. So what is that relationship? Because we want to get to water. Our goal is to get to the moles of water. So what was the relationship between moles of water and ammonia? So it was 4 moles of ammonia. Okay, you guys get 4.8?
Yeah, sure. So you just multiplying what you have by the ratio of that.
So you're going to use that ratio. So it's important that you have a balanced chemical equation so that you're able to get that ratio correct. What was that? Yeah, they're like us. That's anatomy, or I think it's anatomy or physiology. Some bio class.
Physiology is hard.
You see other people come and tell me, should be a little quiet, although I never do it. So.
I did it on the Zoom, so.
Okay.
Microbiology sounds fun. I'm doing that one.
So if we look at this, right? Anytime we're going to be converting, we're going to think about this in terms of going from moles of your quantity of your reactants. If you use that mole to mole ratio, we can get the quantity of our product. So we can always use, if we have a balanced chemical equation, we can get from one point to the other. You have to exactly. So the very first thing that you should always do is to check to make sure that it's balanced. And you also have the right chemical equation. That's off, everything's okay. So how many moles of oxygen are required to burn 2.40 moles of ethane. So we know that this is what type of reaction? It's a combustion. Okay, so first thing that we want to do is write out the chemical reaction. So in a combustion reaction, we know we have ethane. Ethane gas is going to react with what? Oxygen. And then that's going to make what's the product of combustion reactions? Carbon dioxide and water. Is the chemical equation balanced? Okay, let's balance it. Okay, so we know that's not balanced, so what do we need to do to balance it?
Throwing out numbers.
Okay, 2 in front of the CO2. So then that means now we have 4, 5 oxygens.
Three in front of H.
Okay,
So we get 6. But then that'll change the number of oxygen again?
yep. 4 plus 3.
Just kidding. We have to look at fraction.
You gotta do a fraction. Okay, so then we multiply everything by 4, by 2. Okay. So now we have a balanced chemical equation. Yes, sir.
Good. So all we do is multiply the coefficients to the front.
That's right. That's all you need to do is multiply the coefficient. To get rid of them. Okay, so now what are we gonna do? Balance. We've already balanced. Well, we should, yes, definitely should check to see if they're right. So let's go ahead and do that. Okay, so then that's how many carbons? How many hydrogens? 2 times 6, 12. How many oxygens? How many carbons? How many hydrogens? How many oxygens? 14. Okay, so we're good? Okay, so now we know it's balanced. What are we gonna do next?
Move on.
We start off with
Okay, we're gonna start off with our given. Okay, so we have 2.4 moles. Ethylene. Okay,
would we use the
okay. So we'd use the 7. So is that gonna go, we want moles of oxygen, right?
Yeah.
So we're gonna put the 7 on top. Then what's gonna be up front? Two. That's 2 moles of. Okay. So.
other?
8.4. Okay. How many sig figs? 3 sig figs. That's right.
Because of the two
That's why I
point
want
four
to say the
zero.
answer. I don't want to be like, oh, you busy.
Yes, because of 2.40. Okay. Questions? Concerns? Cash? Okay, so we've been kind of lucky because everything has been moles. So we've got to think of moles of like our transition. It's kind of like the gateway drug, right? So if we have mass, we're going to start off with mass. We need to get it to moles. And then we want to get it to moles of whatever else we're looking for. So moles of what you're given to moles of what you want. Okay. And then if we want the mass of what we want to get to the mass. Okay. Now, we have to use that mole to mole ratio in the middle. But if we're given a mass in the beginning, what are we going to get? What are we going to use to get to moles? Molar mass. Exactly. Okay. So this is just basically showing you that whole process and what you're supposed to use to get to where you're supposed to be going, right? So if you're given the mass in grams, you're going to use molar mass, and then that's going to give you the moles of your reactant. And then you can use that and a balanced chemical equation, that ratio, to get to the moles of your product. And then you can use that to get to the mass of that product. And then you can also go to particles if you choose to. Talk about that. Okay. So it says, how many milligrams of nickel 2 chloride are in a solution if 500 milligrams of silver chloride is precipitated in the reaction of silver nitrate plus nickel 2 chloride solution? First thing I want to do is to be what? Okay.
503 milligrams of silver chloride.
Okay, got her given. Okay, anything before that?
We have to figure out their
So we need to figure out the chemical equation. Okay, so okay. So we want to get a chemical equation. So what are the reactants? It's the chloride. Are you sure? Let's read the problem. Let's break it down. It says, the second part here. The precipitant. Ag. Okay, so Ag
And O3.
and O3. Now, Edwin, I'm not saying that you're wrong. I just asked you if you're sure. Are you sure?
When you say that, it makes you never mind.
No, you were not wrong. Because you said nickel 2 chloride was one of the reactions, right? Okay, now what is the chemical formula for nickel 2 chloride? NI? Cl2. Okay, and we know it's a solution, so that means. Okay, what are we making? Product. Okay, what is silver chloride? Cl. Is that going to be solid, liquid, gas, or aqueous? Mike, why don't you whisper something? Solid, liquid, gas, or aqueous? Okay. What type of reaction is this, by the way? Double displacement. So that means what? They split partners. Okay, so then what's going to be the other product? Nickel nitrate. Okay, so nickel 2 nitrate. So then how many nitrates do I need? 2. Is that going to be a solid, liquid, gas, or aqueous? Heard somebody whisper. Aqueous. Is it balanced? Okay, what do I need to do to balance it? Okay.
Yeah, so what is that?
balance now. Okay, so we have a balance. Okay, so what's our given? You told me my given was 503 milligrams of silver chloride. Okay, yeah, milligrams.
That's super small.
And I need to get it to my gateway. Where do I want to get it to? Moles, right? So let me tell you something. Let me share something with you, right? So if I have, what is the molar mass of silver chloride? How would I calculate that? We need that to get the moles, right? Is that 124? 144? Yeah, it's chlorine is 35.45 grams. I believe silver is. What's that? You can't, well, it depends on where it's at. It's right there in the middle, right? So I would never round the. Because it's right there. in the middle. So silver was 143.9 or 8. Like that. What was that?
Wait, what?
Yeah,
So no, it's not like saying,
107.87. Then you said chloride is 35. So you get 143. 132. Okay, so we got 143.40. And units normally is what? Grams per mole. Right? Okay, now we have milligrams. Right? You guys see that? Okay, we're starting out with milligrams, but we also want to get to millimoles, right? So if I have grams per mole and I decide I'm going to use milligrams per millimole, both of these have milli, right? So what is the relationship between a gram and a milligram? It's 1,000, right? So for every 1 gram, it's 1,000. Okay. So what do you think is going to be the relationship between a mole and a millimole? So it's going to be 1,000, right? So in that case, I had 1,000 over 1,000. So my units here, long as it has that prefix milli and milli, it's going to be the same value. Okay, it's going to be 143. You guys understand that? Okay, so I can use 143 milligrams of silver chloride over 1 millimole of silver chloride. Now this would work for kilo. Let's say if I had kilo, same thing. Okay. So now I have moles of silver chloride. How can I get from moles of silver chloride to moles of nickel suggestions? How can I get from moles of silver chloride to moles of nickel chloride? Not yet. When we want to get to the mass, that's what we're going to do. But first, how am I going to, what am I going to use to get to moles of one to give me moles of the other? We're going to use that ratio from our balanced chemical equation. That's right. We are going to use that ratio. Okay. So I have ratio is 2 to 1. So for every 2 moles of silver chloride, put that on the bottom because I'm getting rid of my millimoles. I'm going to have 1 millimole of nickel chloride. Nickel 2 chloride. Okay. So now, Edwin. Now we're going to measure the what? Molar mass. Okay. So how do we calculate the molar mass of the nickel 2 chloride? Florida, how many nickels do I have in nickel 2 chloride? Sure. It's 1. So we have 1 nickel and we have 2 chloride. So nickel is say 693. That's what's on it. Okay. You can round it, but I've rounded to 7, you know, 58.7. And then this one we have 2 times 35.45. Add them together, you said you get what? $129.15. 59. Milligrams per okay, so then we'll plug that in here. That's milligrams. Point 59. Okay. Okay, what do you guys? Not enough space.
But that always happens.
How many safe fakes should we have? Okay, so 227 kilograms. Okay. Escape.
So one.
Kilograms of kilomoles and megagrams of megamoles. So long as the unit, the prefix matches, then you can use that same method. Okay. Okay, everybody got it? Okay, so let me share a story with you. Okay, and then we're gonna have to take a break. So, I think I was just started my second year college, so sophomore. And chemistry was like my wheelhouse. I was a chemical engineer. It was my shit. I was a bomb. And I had a big head. I'm not gonna lie. My head was about this big. So I was taking this class called analytical chemistry. Analytical chemistry is basically you're doing a lot of analysis. So you do a lot of experiments, calculate how much you put in, how much you should get out, or you get out something and you figure out how much you actually put in, right? And so, and you'd always check your percent yield, how much you're getting. Now, of course, we did this on paper and everything like that initially. And then, I get my class and then I was in my first class. That thing, that was pretty well and everything like that. I go in and do my work. And, my partner, I didn't know too much. So I was the one that did all the handling. I go in, I come in, I'm prepped, I have my lab already written out, ready to go check what's going through. The results, I get 84.6%. That's not bad. I need to get 100%, right? I'm around with percent yield.
Percent yield you said what?
Percent yield is the actual over theoretical. Okay. So it's actual over theoretical. In other words, if your experiment works perfectly, you should get 100%. Right? If you've done everything right, you should get 100%. So I go through it again, and I'm like, he's okay, but I don't want to. I want to make it, right? So I'm thinking 100%, right? 100%. So I do it again, right? My lab partner's looking at me, and he's just like, so I do it again. This time I get 84.5%. Wait a minute. No. Something is wrong. So I did it one more time, right? And usually I'm so quick with my labs. I get in, I get out, I'm done, right? Same thing. Now I'm getting a little pissed off, right? And it's around lunchtime, I'm getting hungry, pissed off. So I'm like, something is fucking wrong. I made a mistake somewhere, so let me take a break and everything like that, eat something because I've been pissed. And so I said, you know, I'll talk to the TA, and he has a class in the evening too. So I'm like, is it okay if I come to your class in the evening? I finish up the lab. And by that part, I'm not coming. I'm taking the results of what we got, right? I'll accept whatever we get out of this, right? So I'm like, okay, fine. I'll come by myself, right? He's like, yeah, just turn you do whatever you want. Come if you want to come. I'll see you then. So, you know, I get there and I go to lunch, work it out, do the work. Okay. Take a break and everything like that, do some homework, come back, check it again. You know, okay, so now I'm ready for it. Lab starts at 7. I get over there at 7. Get there real early because I'm like, you know, take 15 minutes to do the lab. I got this down, you know. So I go in like 84.4. What the fuck, right? At this point, I'm getting really pissed off, right? I am like, no. And then, you know, when you start getting pissed off, you start bringing God into it like this. Are you trying to tell me something? You know, and really, I'm like, you know, are you trying to tell me this is not my wheelhouse? This is not where I'm supposed to be? I said, okay, you know, I'm going to take it slow. I'm going to do it really, really slow, right? And I asked this kid, and this kid is known to be like, fucked up, like really big fucked up. You know? He's one of these rich kids whose daddy is giving a lot of money to the school and everything like that. And so they let him do whatever he wants to do anyway. And he's just like a big fuck up, right? And so, and I asked him, he finishes, hey, what did you get? Well, I got 100% yield. And I'm like, you know, this motherfucker get 100% yield. I should definitely be able to get 100% yield. And I'm like, what is wrong? Okay. Go. All right, go it real slow. Fucking 84.6. When I got the very first time I did it, I am pissed. I get so mad. I throw my lab book across the room into the garbage can. I go and keep the fucking garbage can that I was leaving. And then TA comes out. Mr. Henry, what the fuck is wrong with you? I'm like, I got 84.6%. Okay, and what's the fucking problem? He had to last a little bit. He's like, and your problem is what? I don't get 84%, right? I get 100%, right? And he's like, Mr. Henry, and he was just cracking up. And I'm pissed, right? At that point, I'm like, I have a quick temper. You think I have a temper now? I have a quick temper then. I'm like, yeah, let's fight. You know, I'm like, man, you're laughing at me. Okay, let's go, right? He's like, Mr. Henry, calm down, come with me. So he takes me to the back of the class and everything like that, where all the chemicals were. And he pulls out the bottle. I want you to read. What does that say? 84.6% purity. Right? So it was 84.6 pure. Exactly what I ended up getting. How many times did I get it? Almost 4 times. Right? He's like, let me explain something to you. He's like, we're a college. Where are you going to get you the pure stuff? He said, because you guys fuck up all the time anyway. And you guys don't care about getting 100%. He's like, this purity, there's never going to be 100% purity of anything. And he says, and even if it was, you're human. You're going to make mistakes, right? And life is about making those mistakes. And that's what you've got to learn. He says, now get your ass back in there and get your lab notebook. And he says, and finish up this damn lab so I can go home. And so I'm like, you know, and I'm feeling stupid at that point. You know, of course, because you just made a fool of yourself, right? So there's a couple of morals from the story. One of them is, in chemistry, you're never going to get 100%. And if you do, right, you're fucking something up in terms of that yield, right? Okay? Or you're lying, one of the two, right? Number 2, you're going to make mistakes. That's part of chemistry. He is to learn from those mistakes. 3, he got out of the damn thing, right? You can control your own destiny. God ain't telling you anything, right? So if you're going to pass this class, you're going to pass it because you've done the work to pass the class. God has nothing to do with it, right? You have to do it. Okay, so those are my 3 more. Okay, so let's talk about percent yield, and then we got to break down an altar, and then we're going to say peace out today, because I am not feeling my best. So, he lied. He lied. Later on, I looked at his fucking work. He erased things, and he was just like, man,
He
that
was
kid was.
scared about the time you finished.
Oh yeah. So yeah, he was a
She
lying
was like,
fuck.
yep, I got
But
it.
it's funny. So his dad gave me $500 for graduation. His dad knew that the only reason that he graduated was because we actually included him in our study group. We dragged him on, well, partially because he'd always bring food, right? And, you know, so my first 2 years, I had no money for college. My money was being sent to another school.
Is this the same guy you hated?
No, that's a whole nother story. That's the cheating guy. That's Julio. So, no, that is a whole nother story. Yeah,
Yeah, excellent.
whole nother story. But no, this guy he's a rich kid. He would always bring food. So we're like, hey, yeah, we're gonna have him part of our. So we always have food during study session. So, but best gift I have for graduation. Okay, so percent yield is always going to be the actual over ideal, or what we call theoretical. So your theoretical is what you're calculating, or your ideal is going to be what you're calculating. Your actual is what you actually get, right? And again, you're never really going to get 100%, right? Because usually what happens is you lose a little bit here, some of it get lost as you're transferring from one dish to the next dish, right? Somebody spits in it, pee in it, eye drop, whatever, right? So there's so many ways of sitting there and getting those impurities that you will never end up with 100%. Sometimes you end up with 104, and you're like, how the hell did I get 104? It's because your hair fell into it or something. Okay, that's going to happen. Okay, what you want to do is that you want to account for it. The fact that there was an error that's taken, you didn't get that 100%. So that's why we calculate the percent. Okay, so we're going to do this problem, and then we're going to piece out, like I said, I need everybody, because we want to make sure that you guys all get some points for participating, right? So I need everybody to help me break down these alters. So, and if you didn't help build the author, you're expected to really help break down the author.
Oh, yeah, I told some kid I'd give him a fellow if he helped us.
So if we have 3.18 grams of barium chloride, and that's going to be our given. Right? So the very first thing that we want to do is to do what from this? First, let me read the problem first. A solution containing 3.8 grams of barium chloride is added to a second solution containing excess sodium sulfate. Barium sulfate precipitates. Calculate the ideal yield of barium sulfate. If the actual yield is 3.37 grams, calculate the percent yield. Okay, first thing, what? Equation, okay? So we know that we have barium chloride, and that's reacting with excess sodium sulfate. Chemical formula for sodium sulfate? Okay. How many sodiums am I going to need to balance out that sulfate? Okay. We also know that's aqueous because they told us it's a solution. So we know one of the products is going to be what? It's going to be a solid, but what solid? Okay, barium sulfate. Chemical formula for barium sulfate. How many bariums am I going to need to balance out the sulfate? Are you sure? Are you sure? It's balanced, right? Because we know that barium is a group 2 metal, it's always going to be +2. The other product? Okay. How many sodiums do I need to balance out my chloride? Okay. Okay. Is that a balanced chemical equation?
No.
What do I need to do to balance it? Okay, that's what I'm asking. Okay. Okay, so we're starting off with our given, that 3.18. What am I gonna do? Gateway drug is what? Pretty Ricky. I want to get to what? I have grams. I want to get to what? I want to get to moles. How do I get to moles? The molar mass. Okay, so we have one barium. Barium weighs how much? 137. 137.33. And chloride, we already know. We've been saying it all day. There's two of them. So it's 2 times 35.45. Okay. Said 208.43. Grams per mole. Okay, so we know we want grams on the bottom because we want to get rid of grams. So we're going to put the 208 on the bottom. And we want the 1 mole on top. That allows us to get to moles. Now, use that ratio. What is the ratio? One to one. So for every 1 mole, chloride, put it at the bottom, we have 1 mole of barium sulfate. Thank you.
Burial.
So she got extra.
Okay. Do you need tape? Yes, go ahead. You brought some tape. No, I love my class. Especially after that, I mean. I'm sorry. Okay. Okay, so we have a 1-to-1 ratio, right? You guys got 1-to-1 ratio? Good. Okay, so the next thing is that we have to get to the mass, right, of the barium sulfate. So how much does barium sulfate weigh? So we know how many bariums do we have in barium sulfate? We have 1. And we know that that's 137.33. And we have sulfur. How many sulfurs are in barium sulfate? 1. And that weighs 32.06. Okay. Sorry. And how many oxygens do we have in barium sulfate? 4 oxygens. And we're just going to use 16 because I like 16. You said 233.35. Okay. And that's grams per mole of barium sulfate. Okay, so now we want to get to grams, so we're going to put the grams on top. What you guys see? 3 sig figs. Okay, so that's our ideal. So if everything worked out perfectly, that's how much we get. But we actually got 37.37. So how can we calculate the percent? What was that? Okay, first we got to divide it. The actual divided by the ideal, that's right. And then you multiply that by. $94.6. Okay, how many sig figs do we have? What's that? 3? So that should be 94.67. Okay. That's good. Okay, so leave your stuff here.